Yeah. So if you come to Kubernetes architecture, we have master and node. Okay. And what are the master components? What are the master components we have?
API server, scheduler,
API server, scheduler, controller,
etcd,
etcd. And in the node,
kubelet, kubeproxy,
kubeproxy, container runtime,
and
and
pods.
And most of the CLI administration we can do through kubectl and kubeadm. So kubectl is one tool and kubeadm is another tool. Okay, so then after creating the physical cluster, we can create again virtually that can be splitted into namespaces. Okay, if you have the multiple teams, for each team we can allocate the resources by creating namespaces. Okay, so that's what are the default namespaces we will get once we create the cluster. How many namespaces we are getting? By default, we are getting 4 namespaces. What are those?
Default,
Default,
node lease,
node lease,
public, and system.
public and
Kube system.
system. Okay, so what is the command to create the namespace?
kubectl create namespace and
create namespace and that namespace name. Otherwise, through YAML also we can create. Say here, this is the YAML syntax. What is the name of that like namespace we can give? And kubectl create -f that YAML file or apply -f that YAML file we can give. And if you want to delete a namespace,
kubectl delete and the namespace.
That namespace name we can specify. Okay, so then in this here, this command will create a pod. Okay, but if I don't use any namespace name, it is going to create in
in a default container. Default.
In the default namespace, it is creating. That is the reason while creating the pod,
you have to mention
the namespace. Even while retrieving also, if I use kubectl get parts, it displays only from the default. You may be getting confused why my parts are not displaying, okay, are not retrieving. That's the reason we need to use the namespace also. Okay, so now kube system, what is this namespace is? Internal Kubernetes also will have lot of parts. Those are not our application parts. Those are the internal parts. Okay, so those will use kube-system. Kube-system we have. Okay. Then what are the parts? So parts are the smallest units managed by Kubernetes. So parts are the smallest units managed by the Kubernetes. Okay. So a pod may contains mostly one container or one or more containers also we can have. And the pod is going to be encapsulate of one or more containers, their storage, their network can be encapsulated into one single entity. Okay. And pod also we can create as an YAML file itself. In this, we need to specify what is the name of the pod we want and what are the specification of the containers we can have. Okay. So otherwise, kubectl run command also will create the pod. Otherwise, through YAML we can create. A pod mostly can contain a single container, but if both the containers want to share the network same IP, then we are going for a pod with multiple containers. So we can have the pod with the multiple containers, but in the real time we are not going to deal with individual pods. We are going to create the pod controllers. So what are the pod controllers we have? Deployments, daemon sets or stateful sets. Okay, so what is the meaning of deployment? Say declarative updates, say if I have 100 parts also, as a single instance, I can manage all those. Okay, all this can be managed as a single instance. So that is the purpose I'm going for deployments. Declarative updates can be performed. Okay, so this is the YAML file for deployment. In this, how many deployments are getting created through this? One deployment. Then one more resource is getting created, that is replica set. How many parts are getting created?
3.
3 parts are getting created because we have given the 3 replicas. If I given there the 5 replicas, then 5 replicas would be created. And these parts all uses this part specification. And we have added the labels and the matching selectors also. Why we'll add these selectors and all these also we'll discuss in order to match these parts with other resources like services. For those we will use this. So then once we create the deployment, it will create one deployment, one replica set, and 3 parts. Okay, so what is the purpose of the replica set is always at any point of time, minimum that 3 number of stable parts should be running. So that is the purpose we are going for
replica set.
Replica set. We are not directly creating a replica set. When we create the deployment itself, that replica set is getting created. When we create the
Deployment
itself, that replica set is getting created. So why we don't create the replica set directly itself is we can't update rollbacks, all these we can't perform. Only the minimum replicas for the first time we can create. But updates, rollbacks, all those we can do at deployment level itself. But if you want to only without update also you want to create the replicas, then we can go for replica set. And we have one more concept is that daemon set. So why we'll go for daemon set is I don't want to create the replicas. Okay. So if I create the replicas, there is no guarantee each and every replica will run on each and every node. Okay. Some replicas may not run or some parts may not run in the nodes. Otherwise, some nodes may run more replicas also. But I don't have that kind of requirement. My requirement is on each and every
Node.
one pod need to run minimum. One pod need to run minimum. If I have this kind of specific requirement, then I'm not going to create a deployment. I'm going to create the daemon set. Okay, so what is the advantage of daemon set is I no need to specify the number of replicas. How many number of nodes we have?
5.
How many number of nodes we have? In those nodes, one pod would be running. If I have 20 nodes in my cluster,
we should have like a 20 pods running.
20 pods would be running. Okay, so for which type of use cases we'll go for daemon set is maybe storage daemon or monitoring, node monitoring, okay, log collection kind of thing. Otherwise, running a CNI daemon. So it is that CNI also in each and every node, we should have a CNI should be running. Then only that node can report to the master. Okay, so these all it's mandatory. It need to run on each and every agent. So that is the purpose. Like maybe Prometheus, Grafana, Logstash, CNIs. These all need to run on each and every agent. One pod is enough in the node. No need to run multiple. Okay, so for that purpose, we are going for
Daemon set.
daemon sets. And we have one more type of controller is there. We have one more type of controller is there, that is called as
stateful set.
yeah, stateful sets. Before going for stateful sets, so we need to understand services. Okay, so because there is a one prerequisite is there for stateful set, that is a headless service. That means you want to understand stateful sets. First, we need to go for services, and we need to go for PB and PBC also. First, we'll discuss these services. Then we'll come back to okay.
Stateful.
Assume we have created one deployment with the 10 replicas. Then 10 pods would be created. Those 10 pod IPs are very dynamic kind of thing. Those 10 pods are dynamic. That means I can't give that IP address to the users. To expose we are going to use the services. What is the problem is parts are very dynamic, and those are creating, destroying automatically. These all the things are happening. Even if the parts are deleted also, replica set what it will do? Again create the new parts, but new parts will get the new IP address like this. So that is the reason those are keep on changing. Hence, it's not possible to directly access the parts in the dynamic environment. Hence, we are going to create a service, and that service will identify which pod is available at that moment, which is healthy and load balanced. To that service will redirect the user access. Do you understand why we are using services? Directly we can't access the parts.
Replica.
Directly we can't access the parts. Okay, so we are going to manage them through
Services.
Come again.
Services.
Yeah, through the services we are going to expose. So for that we need to attach to the parts. One service need to be attached. The users not directly accessing the
Pods.
parts. Okay, users are accessing through the service. And if I attach a deployment, I may have 10 parts, but service will do a load balancing kind of thing. At that moment, which part is healthy, which is available, to that it would be redirected. So with that, always the application is highly available to the users or not?
Yes.
That is the purpose. It's mandatory. We need to create the services. So what are the types of services we have? We'll discuss. Okay, service is a method of exposing our applications that's running. Okay. So the deployment creates and destroys the parts dynamically. Okay, even if I access the previous part, I don't know that that part may be deleted. Then if I try to access based on the pod IP, I can't get my application. That is the reason don't deal with the parts directly to access. Deal with the services. Even if that pod deleted also, service can redirect to the new pod which is created automatically. And every pod will have their own IP address, and using the service endpoint, we are going to access that. So here we are going to create one service YAML file. And in the pod or deployment, we use the selectors, and that selector and this selector need to be matching. So here, what is the name of this selector we given? Name is my app. We'll go to deployment. Here, this app name, what we given?
Nginx.
But both should be matching. My app or Nginx, like this, based on the selectors, we are going to map them. Both should have the same selectors. Then both are linking. If you give like this, both are two separate entities. They can't link. Here, we need to give app equal to Nginx itself. Then both are getting linked. It's already daemon set is there. Let's. So this is the service. What are the types of services we have? We'll discuss. Say in the Kubernetes, we have the different type of services we have. Okay, so the services we have is first one is ClusterIP. What is that?
ClusterIP.
Second one is Nodeport. What is the second one? LoadBalancer. Fourth one. External name. Say, what is the meaning of ClusterIP is the pod can be exposed, but only within the cluster only we can access. We can't access it from outside of the Kubernetes. Okay, so if I go for the ClusterIP, what's happening?
The pod can be accessed only through the cluster, not from the outside of the
Only
Kubernetes.
within the cluster. That means on the master or nodes only we can access, not from the outside world. Maybe for dev and QA environments, we don't want to access outside, then may go for ClusterIP. But end users can't go to cluster to access the application. Okay, we want to expose the outside to that, then we have two solutions. One is Nodeport and second one is LoadBalancer. So Nodeport is, okay, say any of the node IP and 30,000 to 32,767, using these ports, we can expose our application. So using the node port 30,000 to 32,767, we can expose our
Nodes.
application. From where we can access this? From any of the node IP. If you have 4 nodes, any of the node IP you use. And port number range is
30,000 to 32,767.
32,000 to
767.
32,767 only we can expose. Not possible from other than that range. Okay, can we access outside or not? Outside of cluster, can we access or not?
Yes, sir.
Yeah, yes, we can access from outside of the cluster also. Then we have one more type is there. So normally when we created in the AWS load balancers, we attached the targets like instances, right? In the target group, we attached the instances. But here in this scenario, we can attach to the load balancer, any of the cloud-based load balancer, and AWS we can use, Azure we can use, Google we can use, and we are going to attach the
Services, sir.
the parts are going to attach. The service type itself is load balancer. Okay. Based on the load balancer DNS name, we can access, but it's going to redirect to service discovery is going to happen to the pods. But the main challenge here is for each and every service we required a load balancer is required. So we required a
Load balancer.
Load balancer. Okay. So then one more type is there, external name. Outside I have one domain name, like Route 53 will have a domain name outside, it redirects to internal services, right? Okay, here external name service also outside I have another domain name, but if I click the domain name, it need to redirect to one service inside the Kubernetes. In that the parts are accessible. For that I need to use the external name. If I want to link with any external domain names within the Kubernetes, but for this purpose in the AWS we are going to use Route 53 kind of service. Okay, so here mostly we'll use ClusterIP or Nodeport or load balancers. But even to expose outside, we have one more solution is there, ingress. What is that? We'll discuss. So in this example, we have created one pod and one service. So if you go for this, these labels are very, very important. Okay, here this label and for this service, both we have given. That means this pod and this service both are, that pod and that service is both are linking. Otherwise, that means we can access that pod from this service. And here, this is the service and we didn't give any name of the service, which type we want. Can you guess me? By default, if I don't specify any name, what service it will become? If I don't specify,
cluster,
it will become which service? By default, I'm getting ClusterIP itself. By default, I'm getting
ClusterIP.
ClusterIP. So what is the challenge with the ClusterIP is?
We can't access it from the outside.
We can't access
the pod
it
can be
from the
accessed
outside. We can't access it from the outside. So we can attach multiple ports also. Yeah, here we have. What are the types we have? If we don't specify any type also, it becomes ClusterIP. Okay, so expose the service on a cluster internal IP. But the service is available only within the cluster itself. And this is the default one. Okay. And expose the service on each node port using the port number. What is the port number?
30,000 to 32,000.
Yeah, node port. Okay, we can attach even a node port number also. Then load balancer, any of the cloud-based load balancer we can use. And if you have any external name to that, if you want to redirect to internal services, suppose if someone type api.foo.bot.com example, this domain name with the link, we need to set up this to external name. So for this purpose, we are going for external name. Okay, But what is the main challenge or main disadvantage of load balancer is very expensive because we may have a lot of services. For all those services, creating a load balancer, all this is very expensive kind of thing. For that, we have one more solution is there, Ingress, that I'll explain. So we no need to go for load balancing, and if you want to expose outside, then better to go for want to expose,
Nodeport.
and we don't want to use outside. We don't want to access also. For that, we are going for
Nodeports.
Nodeport, but it's not also chosen for production environments. So now here, try to understand. So what is that service? Kind is service only, but type is
Nodeport.
Nodeport. If I don't give any type,
It will be ClusterIP.
And what is the Nodeport we have attached?
30,000.
30,007. From any of the node IP and colon 30,007 will access our application. Okay. Say in that node, even if the pod is not running also, it proxies that. Okay. So like this, we can access the application using node port. And then we are going to create a load balancer also. Here, instead of this IP, we'll get a DNS name right in the AWS. That IP we are going to use. Means we are attaching to our cloud-based application load balancers or network load balancers using the load balancer. While doing the lab, we'll understand all these, how we can expose all this. Then another one is external name. Say if I have a domain name is there outside, if I access that, I want to access if my database.example.com, if someone types it need to redirect to my service. Then I'm going to use the external name. So this like this we are going to create this. But in the real time also we can use ClusterIP and we can expose outside. So these we'll discuss, but what I want for the stateful set is headless service. Headless service. So what is the concept of headless services? By default, any of the service is going to identify the pod based on the IP address. Okay, but that IP address is keep on changing, but based on the selectors, it can match it. But my requirement is, I don't want based on the IP address because it's keep on changing. I want a unique identifier. That unique identifier is for every pod also will get a DNS name, just like host name kind of thing. That is not going to change. Okay, even if the new pod created also, then I'm not going to discover based on IP address. I'm going to discover based on
IP address.
not based on IP address. Based on the DNS name I want to discover. Then what is the advantage is I can redirect the service to the same pod. If it is happened based on the IP address, it's keep on the pod IP address would be keep on keep on changing. Okay, so it would be keep on changing that one. Okay, but I have some specific requirements. I don't want to go to new pod based on the IP address. I want to go to the same pod. Then I'm going to use the DNS name. But one problem is, if I use the cluster IP, it is going to discover based on IP address.
IP address.
Okay, for that purpose, we need to use a headless service. In the headless service, it's going to discover based on DNS name. It's going to discover based on the DNS name. So this is normal service itself. For stateful set, the mandatory prerequisite is headless service. How we can make a service as headless service is by creating here the cluster IP none. So what is the syntax we need to keep? Cluster IP
None.
none. So if I use this option, what's going to happen?
We're gonna create headless service.
Yeah, it's going to become a headless service. Then the service discovery with the pod not based on pod IP address. It's going to happen based on
Pod.
DNS IP.
pod DNS. Every pod will have a DNS name. Okay. So using that, it's going to discover because the pod IP maybe keep on changing, or if a pod deleted also, we'll get the same pod IP address. So for stateful applications, this is the mandatory requirement. We need to go to the same pod, but we can't discover that because the pod IPs are keep on changing. That's the reason we require a unique identifier. That unique identifier is the DNS name. That unique identifier is DNS name. So how we can declare the headless service?
By giving the value none.
Yeah, cluster IP should be
None.
none. So this is the prerequisite for stateful set. For deployment or daemon set not required, but for stateful set. Okay. So what is the meaning of stateless applications and stateful applications? We'll discuss. Stateless application is maybe front-end kind of application. Okay. Say, I can go to any of the pod, my application is available. But if I go for a stateful application, I have my session is there. Okay. And I have something added into my session. Okay. So then if it redirect to the new pod, user experience would be bad. Okay. For stateless applications, you can choose deployments, mostly for the front-end microservices. For the front-end microservices, we are going to choose
Stateless application.
Yeah, deployments we are going to choose. So most of the front-end applications are stateless because even if you go to any front-end UI also, it's same. And if you go for the stateful applications, I'm going to create the stateful sets. Maybe for the backend, like maybe Java Spring Boot, otherwise even if my database is running as the Kubernetes or NoSQL kind of things, for all these, better to use the stateful sets. Okay, for monitoring agents, log collection agents, storage nodes, CNI, for these kind of things, we'll choose
Daemon set.
daemon set. Okay, so for stateless applications, we need to use deployment. For stateful applications, we need to use the stateful sets. And for monitoring agents, we need to use like daemon sets. Depends upon our requirement, we need to choose. Okay, if I don't give the stateful set for the backend applications, each and every time user session is going to be lost. Okay, so that is the purpose we are going for stateful sets for those, for the backend applications. Okay, so how the stateful set, what is the advantages and how the persistency will come, we'll discuss. In order to manage the stateful applications, that means user session need to be same server, it need to redirect. Okay, so then what is the stateful set guarantee is the user request will go to the same pod. For that, for every pod, we require a unique one. That unique is not IP address because it's keep on changing. Okay, the DNS name is the unique. Okay, same pod is getting created, but with the deployment, what is the problem is we don't get the same pod ID. It may be a new pod ID would be created, but with the stateful set, the same unique ID of the pod is getting created. And even if that pod deleted also, again we'll get the same ID. But which one is changing in that scenario?
IP address.
IP address. So for that purpose itself, to discover in that scenario also, we are going to provide the solution is
Stateful sets.
No, headless service.
Headless service.
Okay, so that's the headless service is the mandatory for headless service is mandatory for
stateful sets.
For the stateful sets. Headless service is mandatory for the stateful sets. What is the difference between deployment and stateful set is unique and ordered parts. Ordered means part 1, part 2, part 3. Like this in ordered way, it's going to create. And even update or rollbacks also, it happens in an order itself. Unique and ordered set of parts are created through
Stateful sets.
But those not created in deployment. Deployments are the best method for stateless applications. For stateful applications, it's recommended to go for
stateful sets.
And for the data persistency of these deployments, for stateful set, definitely it's required persistency also. That's the reason we are going to attach the volumes. So in the Kubernetes, volumes are called as PV and PVC. PV and PVC we are going to attach. Okay. So what is that meaning is even if my pod deleted also, a new pod is getting created. Even with the deployment also created. Who is responsible for that? The replica set is responsible for that. Replica set would be keep on monitoring whether that minimum number of pods are running or not. If those pods are not running, then automatically it tells to the scheduler to schedule a new pod. Based on the specification of the deployment file, one pod based on those image and the name specifications, container ports, based on those details is going to create one more pod. But in the stateful set also, a new pod would be created, but with the same pod ID, we are going to get it. With the same pod ID, we are going to get then user request need to go to the same pod ID, but one problem is the IP address may be changes. That IP address may be changes. In order to avoid that one, what we are going to do?
We have a headless service.
We are going to use the headless service. And for the persistency of the pod, even if the pod deleted also, the data should be persistent. That's the reason we require PB and PBC. It doesn't mean for deployment, we don't need of PB and PBC. Even for deployment also, we may want the logs and all those all we can store in the PB and PBC. By adding a persistent volume, it won't become a stateful set. What we required? A unique and ordered parts were required. Unique and
Ordered parts.
so that's possible only with
Stateful sets.
stateful sets. So by using the stateful sets, this is the advantage. Ordered graceful deployment is if I have 100 parts, first 2 parts, 1, 2, 3, 4, like this in ordered way also, it's a systematic way it happens. Rollback also happens in an ordered way. It almost looks like deployment, daemon set, replica set, all looks like same itself. But in this scenario, so this is the stateful set. First, we didn't create the stateful set. Okay. First, we created a hello? Am I audible?
Yes, sir.
Okay, sorry, I lost the internet. Okay, so now here, when we are creating a stateful set, can you tell me what is this?
Headless service.
Headless service. How we can tell that is an headless service?
So the cluster IP is none.
Cluster IP is none. And what are the labels we have here? Selector labels. App is Nginx. Then here we mapped this. That means that headless service and this stateful set is matching. Okay, so then this is not a deployment. This is a stateful set. And how many replicas are created?
3.
3. That means 3 replicas would be created. And here we have attached PVC also for the volume. Whatever the data we have in user share Nginx HTML is going to store in one volume. With that, what is the advantage is, even if the part deleted also, that HTML data is persistent. That HTML data is
Persistent.
Persistent. What is the advantage is, even if the part deleted also, new part would be created, will get the same part ID and the data is
persistent.
But only the problem is that IP address has been changed. For that, we given the solution is
Headless service.
headless service. So that is the purpose we are going for stateful sets with a headless service. Okay, so here
The path is available locally, sir.
come again.
Path, sir. Is it available locally?
Which one?
The mount path, sir. Like the user share, Nginx, HTML.
No, that is
paths are locally
inside the container path that is.
Oh, okay.
That is attached to one EBS volume.
Oh.
In the AWS that we are attaching a volume.
Yes, sir.
The advantage is even if that part deleted also volume is persistent.
Okay, we can map that.
A new part also will use the same PVC.
Oh, understood.
That is the reason the data is persistent. Otherwise, if I give a new part without having the data, there is no use of that part getting created.
Yes, sir.
Okay, so for the data persistency, we are using like a PVC, and stateful set will give the unique part also. Same part is getting created again. That's not possible with deployment.
Okay.
Hence, for stateful applications, we are using stateful sets, stateless applications, but try to compare what is the difference between stateful and stateless applications. For the front-end microservices, we'll use. For the front-end microservices, we'll use
stateless
deployments.
Yes.
For the back-end applications, we'll use
stateful.
Stateful sets, we are going to use it. Okay, any doubts on this? So try to create all these Kubernetes cluster, try to do. Okay.
Yes.
I'll stop here.